All right, everyone, welcome back to part two of assignment three's video lessons. So for this one, now instead of day one notes, you're gonna wanna have your day two notes in front of you. So we're gonna go through a much quicker PowerPoint presentation for this one. And then you'll have these worksheet number two problems to solve at the end, right? So after the first lesson, you've taken notes, you've done worksheet one. Now you're on the second part of the lesson and you're taking notes on day two and you're working on worksheet two. Okay, so at the end of assignment one, you're gonna submit worksheets one and worksheet two. You're gonna submit those for a grade. Okay, I don't need your note catchers, but you're gonna want them as you keep working on assignments for this lesson three. Okay, so we're starting off with day two notes and we're gonna start off here still talking about the mole. Okay, this time, instead of just going between moles and number of atoms or number of molecules, this time we're going to be talking about how we can bring mass into the equation here. How can we bring mass of your substance, right? So if you have a glass of water and it has a mass of 100 grams, right? How many moles of water, H2O molecules, are in your glass of water? Or if you have a pound of gold, how many molecules of gold or moles of gold are inside of your 1 pound of gold? So let's take a look at problems like that in this lesson. So you're following with your note catcher. Two goals here, right? So first you want to be able to calculate what's called the molar mass of a substance, right? So we're going to introduce this new term, molar mass, and we're going to define it. Then we're going to use that molar mass and we're going to calculate the mass of a substance if we're given the number of moles. Okay, so if I tell you, hey, you've got 3 moles of oxygen molecules, you're going to be able to tell me the mass, how much those 3 moles actually have a mass of. Okay, so here, looking at atomic mass versus molar mass. Okay, so at the start of the first part of the lesson, I told you needed a calculator, which we used in the first half, and a periodic table. Right, so now's the time to whip out your periodic table because we're going to start referring back to the periodic table. And if you don't have one, there's a PDF in the Google Classroom assignment that tells you or has a periodic table for you to use. Otherwise, look in your agenda, look in your chemistry binders. You might have a bunch of periodic tables lying around. Okay, so if we look at the definition for atomic mass, this is a number that we find on the periodic table itself. Okay, so we can look at a periodic table and we can find the mass of a single atom in AMU, atomic mass units, right? You know atoms are incredibly tiny, right? So we can't measure their mass in grams. We can't measure their mass in pounds. We have to use this new unit called AMU, which describes a really, 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 really tiny amount of mass, okay? So for example, 1 carbon atom has a mass of 12.01 AMU, right? Very, very, very small mass. If we open up our periodic table, then we'll see by zooming in here, we'll see that the atomic mass is actually written right underneath each element, right? So for carbon, for example, this number down here, right? A lot of you are asking me, what does this number mean? Why are there a bunch of decimals here? And this number tells you the atomic mass of any given element in AMU. Okay, so 12.01, that's how much 1 carbon atom, that's the mass of 1 carbon atom in AMU. Now, the interesting thing about the periodic table, I should say, is that same number, that same atomic mass, we can use for other things. So if we take a look at carbon, for example, the atomic mass is 12.01 AMU, but also the molar mass, right? The mass of 1 mole. How much does 1 mole of carbon atoms, what mass does it have? Right, so the molar mass is different. We're talking about 602 septillion carbon atoms here, right? So we're talking about a big, massive bundle of carbon atoms. Actually, they have the mass, the same exact number, 12.01, but this time grams. Okay, so 1 mole of carbon atoms is 12.01 grams. So if you have 12.01 grams of carbon in your hand, you've got 1 mole of carbon atoms, okay? So this is a very important idea that we're gonna use now for the rest of the lesson. Okay, so the molar mass examples here, we have this molecule here that has 2 Als, right? 2 aluminums, we know because it has a subscript, and then 3 sulfurs, 3 S's. Now, what's the molar mass? How much would a mole of this molecule, what mass would it have? Now, we take the molar mass of each of the 2 elements, right? We take the molar mass of Al, and first of all, a lot of students ask, where do you get these masses? Where do the molar masses come from? Right from the periodic table. So if I look at Al, I see that it's got about a 26.98 molar mass, right? 1 mole of aluminums is going to have a mass of 26.98 grams. Okay? And then the same thing for sulfur, S. 1 mole of sulfurs is going to have a mass of 32.06 grams. Okay, so that's where I'm getting my molar masses from, the mass of 1 mole. Okay, so if I look back to this example problem, I know that my molecule has 2 aluminums. So what I'm going to do is I'm going to take the molar mass of aluminum right from the periodic table, and I'm going to multiply it by 2, because I've got 2 atoms of aluminum in that molecule. So a mole of that molecule means I have 2 moles of aluminum molecules, or sorry, aluminum atoms. Okay. So I take the molar mass from the periodic table for aluminum, and I multiply it by the number of aluminums, and I get 53.96. Do the same thing for sulfur, right? There's 3 sulfurs in this molecule, 3 times the molar mass of sulfur straight from the periodic table, right? The 32.07, and I multiply that. And then what I have to do is I have to add up the molar masses of each element, right? So the 2 moles of aluminum have a molar mass of 53.96, and the 3 moles of sulfur have a molar mass of 96.21. I add them together to get the molar mass of the whole molecule, right? And then I usually, whenever I do these calculations, always round to the 2 decimal places, the nearest hundredth. Okay, so all in all, 150.17 grams of this molecule, Al2S3, is going to be the mass of 1 mole of that molecule. So once I have this amount of this molecule, I know that I have a mole of that molecule. Okay, I know that I have a mole in terms of number. Remember, a mole describes the number of molecules, whereas grams describes how much mass. Like if I told you a dozen eggs weighs half a pound, and then I told you you have 1.5 pounds of eggs, how many dozens do you have? You'd say I have 3 dozens, because each dozen weighs half a pound, right? Each mole here has a mass of 150.17. So if you had 300 grams of this molecule, you'd have about 2 moles of that molecule. Okay, so let's try one more example here. Now here you have one of these molecules that has the parentheses, and it looks a little bit complicated, but use your balancing equation skill here when you're trying to figure out how many of each element I have in this molecule. Right, so the exact same way when you balance your chemical equations, you're going to distribute your subscripts on the outside of the parentheses. You're going to follow all the same rules to figure out how many elements are in this molecule. So let's take a look. First, we start with the barium, the Ba. Okay, so here we've got 3 bariums. That means that in a mole of this molecule, I'm going to need to calculate 3 moles of this Ba barium guy. So again, straight from the periodic table, I look right underneath Ba, barium, and I find this molar mass right here, 137.33, right? And make sure to check your periodic table to make sure that I'm correct here, right? So this should be right under your Ba on your periodic table. And then I multiply this by 3, because in this molecule, I've got 3 Bas hanging out. And okay, I multiply that and I leave that off to one side. Then right underneath there, I move on to my phosphorus, my P, and then I realize I've got 2 phosphorus here. How do I know that? Because inside the parentheses, there's no subscript in front of the P. So there's a 1 P inside of the parentheses. And then I take my 2 out here and use my distributive property to multiply by everything on the inside of the parentheses, right? So I know I have 2 phosphorus here, right? So I take my 2 and I multiply it by the molar mass of P, phosphorus, which comes from the periodic table. Multiply that move that to one side, okay? And then last, I take my oxygen. Inside the parentheses, I've got 4 oxygen, so I multiply that by my 2 outside the parentheses. I've got 8 oxygens in this molecule. So if I have a mole of these molecules, I would have 8 moles of oxygens. Okay, so I'm multiplying 8 times 16, which comes right underneath O, oxygen, and then I get 128. Whew, okay, now I've done the molar mass calculations for all of my elements inside of my molecule. Once I've done that, I can add them all together. So you want to make sure that as you figure these out, you're writing them in a straight line off to the right side of your paper underneath your problem. And that way it's easy for you to remember to add them all up at the end, right? So 3 BAs, 2 Ps, and 8 Os. Multiply each of these by the molar mass for each element, and then add up all of those products, add them up, and you'll get the molar mass of this molecule. So about 601 grams of this molecule, 601.93 grams of this Ba3PO42. 600 grams of this is about the mass of 1 mole of those molecules. Okay. So let's do 2 more examples just to make sure that we get it, and we're making it a little bit more complex as we go so that we can solve cooler and cooler chemistry problems. Next, we want to figure out what's the mass of 1.33 moles of the molecule we were just talking about in the last slide, right? So this barium phosphate. Well, what's the mass of 1.33 moles of this? So we know, right? You want to do your K and your U, known and unknown, right? Lay out what you know and what variables you need to figure out. So here for your knowns, 1.33 moles of this molecule. Okay, no worries. And then we look at unknowns. We want to know how many grams that is, right? And so we need to know, first of all, we've got 1.33 moles of this thing. Okay, we put in our our placeholder here, because we're going to do a little bit of dimensional analysis, right? If you stop and think about this, thinking about the first lesson too, when I do this dimensional analysis, I'm looking to end up with my unknown unit. I want grams to be at the end of this, right? I don't want moles to be at the end. I want to solve for grams. So essentially what I'm going to do is I'm going to take the molar mass that I figured out in the last step. When I added together all those molar masses, that's 601. This molar mass helps us convert between moles and grams, because this molar mass tells us the relationship between the mass in grams and 1 mole of the molecule. So here, I can take the 1.33 moles that I was given in the problem, put them on top here, and then multiply by the molar mass. And you want to be careful that you put on the bottom, you put the units of what you want to cancel out, right? So in this case, I have moles up top here, so I need to make sure that my 1 mole goes on the bottom here. And then my 601 that I calculated in the first step of this problem, my 601.93 grams, this remains on top. So then I know I'm doing things right, because my moles here will cancel out, and I'll be left with just grams of this barium phosphate. Okay, so then I do my multiplication across the top, right? So I have 1.33 moles times the 601 grams, and then the ones on the bottom multiply, right? And so the top number divided by 1 is just the top number, so we don't write the 1 in the answer. And we have 801 grams of this Ba3PO42, barium phosphate. So essentially, we're in this problem, we're saying in 1.33 moles, 1.33 bundles of barium phosphate molecules, that 1.33 bundles of molecules will have a mass of about 801 grams. So once I hit 801 grams, you can, if you have a beaker full of barium phosphate, you pour it out onto the scale. Once you hit 801 grams, you know that there's 1.33 moles of molecules on your scale. And that's pretty cool, because you're linking a world you can't see, counting molecules to a world you can see, which is measuring the mass. We can all measure the mass, but we can't see the molecules that we're measuring. So it's really cool to have a way of figuring out exactly how many molecules are in exactly how many grams for a given substance. Okay, and so last example here before we call it a day here. How many moles are in 157.8 grams of calcium chloride? So CaCl2. So we're going from grams to moles. If you have 157 grams of calcium chloride, which is a salt, you can hold it in your hand. How many moles, how many molecules of that CaCl2 do you have? So let's figure out this one. Our known is the grams of CaCl2 we have. Our unknowns is going to be how many moles. Okay, so the very first step is we have to figure out the molar mass of the CaCl2, right? So figure out how many CAs you have, right? How many Cls you have, multiply, right, the Ca molar mass by 1, multiply the Cl molar mass by 2, and then add them all together to get the mass of 1 mole of this molecule. Okay, that way we can work with it when we're trying to go from moles to grams or grams to moles. So let's take a look at this. We start off with our known. We have 157 grams of this calcium chloride. We put our placeholder 1 underneath. And then we want to multiply, right? We do the math on the side. So there's going to be a little bit of math here, right? So on the side, you can calculate the molar mass. You can say, okay, 1 Ca 1 times the molar mass of Ca, straight from your periodic table, right? We're not making up this number. This comes from your periodic table. And then 2 times the molar mass of Cl. So 2 times about 35.45. This will give you 40 for Ca. This will give you about 70.90 for Cl. You add them together, and then the molar mass of this molecule, CaCl2, is 110.98. So that way I know that for every 1 mole, it has a mass of 110.98 grams. Okay, so then I figure out, how do I put this into my calculation here? I start off with 157 grams, but I want moles at the end. So this time around, I'm gonna put the grams, right, the molar mass on the bottom here, 110 grams on the bottom. And on top, I know that this mass corresponds to 1 mole of this molecule. So by figuring out the molar mass, I know the mass of 1 mole. Okay, so I plug it in like this. I know I'm doing something right when my units on the bottom here cancel out with my units up top. And then I'm left with mole units. And then I do my multiplying across the top and across the bottom. Okay, by multiplying across the top, I get 157.8 times 1, right? So 157 on top. And then I know I have to divide by this bottom number because it's down here, it's the reciprocal, it's down at the bottom. So I know I'm gonna have 157.8 divided by 110. So my answer here is gonna be about 1.42 moles of calcium chloride. Right, so I started off with a mass, 157 grams, and I know that that mass equals about 1.4 moles or bundles of CaCl2 molecules. So for this one, really it's going to take some practice, right? Worksheet 2 asks you to practice going back and forth between moles and grams, okay? And so the very first thing you want to do, right, as you're looking at those problems, the first thing that should come to mind is, I have to calculate the molar mass. I need to know what the mass of 1 mole of these molecules is. So you whip out your periodic table and you make a chart just like this. List out all of the elements in your molecule and how many of each element you have, and then go through step by step, multiply the number of elements in the molecule times the molar mass of that atom. I'm sorry, of that element. Right, so I only have 1 Ca in this molecule, so 1 times, right from the periodic table, 40.08. And then do the same thing for all the elements, and then add up all of those products into 1 number. Okay, that's how you get the molar mass, the mass of 1 mole of this molecule. Okay, so very first step here, molar mass, and then plug in your known, and then you'll multiply by your molar mass. Either multiply by the molar mass number, or divide by the molar mass number, depending on which one cancels your units. Okay, so you're left with your unknown at the end. Okay, so this can be a little bit of a challenge. I think you're all up for it. And if you need some help, you can always log into Zoom sessions Tuesday mornings 10 to 12 and Thursday afternoons 1 to 3. All right, so good luck, have fun, and I'm looking forward to grading your work.